Okay, so we're halfway through the review. So for this one, the question 7 says, a surveyor needs to determine the distance between 2 points that lie on opposite banks of the river. The figure shows that 300 yards is measured along one bank. The angles from each of this line segment to a point on the opposite bank are 62 degrees and 53 degrees. Find the distance between A and B to the nearest tenth of a yard. Okay, so for this one, let me just make sure you can see it all. Okay, so I'm gonna go ahead and write the numbers a little bigger so that you can see them. And up here we have 300 yards. And this is A, C, and B. Okay, so it's wanting to find the distance from A to B. Now, like in question 6, this triangle is not a right triangle, so we cannot use trig ratios to figure this out. So we're either going to use law of sines, law of cosines. So I'm wanting to find a side that is not in the middle of two angles. So that is a sign that I'm going to use the law of sines. So I'm going to go ahead and write out my law of sines so I can see which ones I'm going to use. And sine C over C. Okay. So if I have big A over here, right across from that is going to be little a. Big C is right up at the right top, so right across from that is going to be little c. Big B is on the bottom, so right opposite of that is going to be little b. So if I'm wanting to find this side, I know that I'm going to use the one with my sine of c and little c. So that one's for sure. So now figuring out which one of these to use. Well, let's see. So I have my angle A, which is 62, but I don't have the side A. But I have side B, but not angle B. So you have to ask yourself, what's easier to find, an angle or a side? So if this was a right triangle, I would say side, because you can just do the Pythagorean. But since this isn't, we're going to go ahead and find the angle. So what do we know about all triangles? So no matter what the size or shape of the triangle, if I add all 3 degrees, that will give me 180. So what I'm going to do is add these angles and subtract them from 180, and it's going to give me the degree of the missing angle, which is 65. So now I have a complete angle of B and my side of B. So I'm going to be using this one. So let's go ahead and fill in what we have. The sine of B, which is 65, so sine of 65 over my little b, which is 300, is equal to sine of C, which is 50 degrees, sine of 53, over little c, which I don't know what that is. So what I'm going to do now is I'm going to flip both of my fractions. Since my variable's on the bottom, it's easier to figure out what it is when it's on the top, because we're going to have to flip it eventually. So let's just go ahead and do it now. So my c is going to be on the top, my sine of 53 will be on the bottom, and my 300 will be on the top, and my sine of 65 will be on the bottom. So now all I need to do is multiply by sine of 53 on both sides. That will get rid of my denominator, so on the right hand side I'm just left with c. And on the left hand side I'm going to multiply sine of 53 times 300 divided by sine of 65. And once again, make sure that your calculator is in degree mode and just go ahead and plug it in. 300 times sine of 53 over sine of 65. And it's going to give me 264.359. We want it to the nearest tenth of a yard. So I'm going to go ahead and round my 3, which will give me 4. So my answer is 264.4 yards. And that is the distance between A and B.